Hey there, class. Today we are going to look at writing something called a net force equation. I'm going to abbreviate this with the abbreviations NFE. And we learned in a previous video something called about an FBD, or a free body diagram. If you need to refresh your memory with that, I will have some links for you to check out those videos as well. So to start off, let's kind of clarify some terminology. Net force equation isn't necessarily going to be something that you see in maybe a physics textbook or anything. This is kind of something maybe I've developed, maybe I've picked it up from somewhere, I'm not sure where. But the reality is I have seen this different ways. So let me write out Newton's second law. Newton's second law says that the sum of forces equals mass times acceleration. And while I understand that this stands for net force, okay, I fully understand that that means net force, this is not the net force equation. Okay, this is what I call Newton's second law. The net force equation is what we're going to get after we've substituted variables into Newton's second law. So it's going to look something more like this. Instead of seeing sigma F there, you're going to see something maybe like this. Maybe it'll be a force applied plus, I don't know, the force of friction or something to that nature. And that's going to equal the mass times acceleration. And of course, acceleration is a vector here as well. So again, this is the net force equation. What I'm defining as a net force equation does come from Newton's second law, and we'll see that here in just a bit. But as far as are they the same thing, they are not. So when you hear me say, what is your NFE or your net force equation, I am not talking about Newton's second law. Newton's second law is this. This is a net force equation. Okay, so when it comes to writing a net force equation, there's going to be two options here that I'm going to show you. Option one is where we can take the vector directions and put them on the variables. And you're going to substitute only in magnitudes when you actually do the actual substitution of numbers. Option two, on the other hand, is you're going to substitute both magnitude and direction into the equations. And so I'll kind of take you through what each of these looks like. Okay, so the first thing that we will do is we're going to actually take a look at our free body diagram. If my goal is to find the normal force here, basically I want to look at the y direction, the up and down direction, and I notice there's two forces that are here. So having a completed free body diagram is super important. You need to have all your forces drawn on a free body diagram. Again, if you need to refresh your memory with free body diagrams, I have some videos about that. The next thing I do is that since Newton's second law tells us that the sum of forces equals mass times acceleration, I'm going to simply add these two forces together. Now notice these are still listed as a vector. Okay, they still have vectors, so these are being added together. So far our two options look identical to one another. One simplification that I might make here is the fact that acceleration is actually 0. So I would actually put the 0 in kind of in my head and say that I know this side of my equation is going to have to equal 0. Okay, so that would be one thing that I do. Usually I try to substitute zeros in early on in the process. Okay, so taking a look here in option 1, basically in option 1, let me kind of zoom in here on what we're doing, but basically in option 1, we take that net force equation. This is the net force equation right here. And here I'm going to actually substitute in the magnitudes down here. This is a magnitude being substituted in, but the directions are substituted in where I on variables. So you'll notice here that basically I use the fact that this is being substituted in over here. Next, as I work this out, again, notice the vector symbols are gone here, so I know that I have my directions here and my directions there. So this is what makes it a vector. Doing some algebra, I notice that it's going to be the normal force minus the gravity. I substitute in just a magnitude here. Okay, notice it's being substituted as 22. And then to get to this next step, I simply did some algebra, and the algebra, I'm going to bring the 22 over to the other side. And so I end up getting the 22 newtons as the magnitude of my normal force. Now, on the other side, if you prefer to look at this from the standpoint of substituting directions and magnitudes at the same time, basically we're using this substitution right here. And this is what gets substituted over here. So again, starting with Newton's second law, I write my net force equation. What I've done here is I've substituted in the negative 22 for the force of gravity. The force of gravity, again, being a negative because that's the direction. And it's 22 magnitude is going there. So then to go from this step to this step, I am simply doing some algebra here to get that magnitude of the normal force, and that is how we do that. So a net force equation is really important that we have a good free body diagram first to do that. Okay, so to summarize, to write a net force equation, the first thing is, and this is absolutely critical, we have to have the correct free body diagram. If this is not correct, if it is not completed, there is no way that a net force equation, regardless of how good we do it, is going to solve the problem. You must absolutely, positively have this free body diagram correct. So next is all the forces in a direction get put into our net force equation. Typically, we split our directions into x's and y's. So we want to, typically, we're going to write our net force equations separated by the x direction forces and their y direction forces. So you want to make sure that you're putting them all in the net force equation. Again, all the forces affect how this thing moves. So we don't simply say, oh, well, I just want to ignore this one. All of them need to get put in there. And last thing to make sure is that you are keeping track of the direction somewhere. And again, I've shown you up here two different ways you can kind of think about that. You can either substitute the directions in on the variables, or you can substitute them in, as I showed over here, when you substitute in your values, you're substituting in the magnitude and the direction at the same time. As long as you're consistent with it, it's going to work out for you. But these are just some of the things that you should remember when you're doing a net force equation.